All right, so the idea behind this video is to practice looking at data in something called a two-way table. And so the reason we call it a two-way table is because data is being presented and compared across two different categories. So we've got the responses that people gave on a survey, and then we've got those people categorized by age. So vertically, we've got categorizations, yes, no, no answer, and even some further ways to classify those people. But horizontally, we've got how old everyone who took the survey was. So each number inside of this table is going to represent a person who fits into two different categories. And in this case, sometimes even three different categories. So I'll read the situation, and then we're going to do some practice problems where the video will pause, and you'll be asked to answer the question before you can move forward with the video. So the school board of Waldo, a rural town in the Midwest, is considering building a new high school primarily funded by local taxes. They decided to interview eligible voters to determine if the school board should build a new high school facility to replace the current high school building. There's only one high school in the town. Every registered voter in Waldo was interviewed. In addition to asking about support for a new high school, data on gender and age group were also recorded. The data from these interviews are summarized below. And so before we even get started at asking any questions about this data, what you should get in the habit of doing, if the data isn't already provided, is figuring out how many people are in each of these categories and putting a little total, and I may move this, a little total beneath each column and next to each row. So for example, if I just take a look at the people who said yes, who were male, how many of those people were there? And if I add those numbers together, 29, 53, 30, and 7, I'll get 119. And so I'm just going to do that for each of my columns and do that for each of my rows because it's important to have that information in front of me. Otherwise, I may just be recounting the same numbers over and over and over again throughout any problem related to this two-way table. So in column 2, I've got 154 people who were female and said yes. I have 116 people who said no but were male, and 114 people who said no but were female. And then there were 6 males and 6 females who did not answer the survey. If I go horizontally and I focus on age groups, between the ages of 18 and 25, it looks like we had 75 people answer the survey. 26 and 40 was 203 people. There were 149 people between 41 and 65, and then 88 people that were 66 and older. And so another important number to have here is then how many total people took this survey. And they did say that every registered voter in Waldo was interviewed. So really what we're asking here is how many registered voters are there in this town? And if I add up all of these numbers, I get 515, and I should check to make sure that that's actually true of these numbers as well. And when I do that, I also get 515. So that just lets me know that I didn't make a mistake in adding my numbers together, because if those came out differently, then it would be likely that I did something wrong when adding. Okay, so now we're going to ask our first question related to the data given in this table. So now if I were studying the results of this survey, I might ask a question like, say I pick a voter, a registered voter from Waldo at random. What is the probability that that voter said no on the survey? So that's the question that I'm asking here, and the video is going to pause in a second. What is the probability that someone in this town said no to the survey? So what we're going to see now is the solution to that question. So the probability that someone said no to the survey means that they are in this column. So that's going to include all of the males and females who said no. So using my notation here, I'm just going to write out what it is I'm doing. The probability that someone said no. So what I want to know is what is the number of people who said no divided by the total number of people who took the survey, people in the sample space. And obviously we have 515 people in the sample space because that's our total number. But how many people said no? Well, it's the 116 males plus the 114 females that said no. So 230 people said no. And we do want to reduce this fraction. So if you didn't reduce the fraction, that would be marked incorrect in this case. We want to reduce these. That's the habit we're trying to get into. So we're going to look for a common factor of 230 and 515. And if you're using a scientific calculator, you can try dividing those by some common factors, but you'll find that they're both divisible by 5. So we're going to reduce this to 46 over 103. So that would be the answer to that question. That's how likely you are to find a person who took this survey and said no. Okay, let's ask another question then. What is the probability that a registered voter in this town is 66 and older and said yes? So what's the probability that a person is 66 and older and said yes? All right, so this is slightly more complicated, and this is an intersection question. We're now using and. So what's the probability that I find someone who's 66 and older and, so I'm going to use my intersection symbol here, said yes? All right, so where are the people who are 66 plus and said yes? Well, they are here. Those are the people who are 66 and older and said yes, divided by the number of total people in the sample space. So out of 515 people, I have 7 of them who are male and said yes, and 26 of them who are female and said yes. So that leaves us with 33. It's important when we look at this intersection, right? It's got to be people who fit both of these criteria. So the 66 and plus people are here, but I can't include these 66 and over people because they didn't say yes to the survey. And although all these people said yes to the survey, these people are not 66 and over. So with the intersection, we're really focusing in on a small number of people usually. Now I'm going to ask the same question, but I'm going to change that one specific word that we discussed yesterday is pretty important. Rather than asking who said yes and was 66 or over, I'm going to say, what's the probability of selecting a voter at random who replied yes or is 66 and older? And so when we calculate that, it's a little bit different because now we're using a union. So 66 and over or said yes. So remember, we've got that addition rule formula that we can use here, and I'm just not going to use it in this case because we can see these numbers so clearly in the two-way table. So when I calculate this, I need the number of people who selected 66 and over or said yes, divided by the number of people in the sample space. There are 515 people in the sample space, so now I'm just going to go through and pick people who are 66 and over or said yes to the survey. So these are all the people who said yes, right? So they're all included for sure. So I'm going to take these people here, these people here. 66 and older people are all in this row here. So I already have the 7 and the 26. I'm not going to count them 2 times. But I am also going to count the 24, 29, the 2, and the 0 people there. I'm not including anyone in any of these groups because they don't meet either of these criteria. Remember, now that I've changed it to a union, we're talking about or. So anybody who either said yes or is 66 and older is going to count. So these are all the people in those groups. So now we can add up those totals. All right, so we've got the 119 people, plus we have these 154, plus we also added in these 24 people, these 29 people, those 2 people, and I don't need to add plus 0. So that's going to come out to 328 individuals. So you can see how different the question becomes once we change that word and to or. And we can't reduce this, so that would be your final answer there. And I want to try to keep these videos around 10 minutes, so I'm just going to ask one more question. What is the probability that a registered voter did not answer the survey or is between 18 and 25 years old. So I want to know what the probability is that there was no answer or they were between 18 and 25 years old. So I'm going to need the number of people in those groups. Divided by the total of number of people in the sample space. And I am still writing out this formula every single time, just so that hopefully this gets embedded within us, that this is the format we're always using. Eventually our calculations will get a little bit more advanced and we won't probably write this step over and over because you are probably starting to feel like it's pretty redundant. We just keep writing the same stuff. But there's a reason for that at this point. So who are the people who did not answer? Well, that's these 6 people and these 6 people. They did not answer the survey. But we also have some people who are between 18 and 25, and that's these people. So I can add all those together, but I have to remember that I don't want to double count anything in the intersection. So I'll add those. I'll say that that's the 6 people plus those other 6 people plus those 75 people, right? So these are my no answer people, and I'm going to add to that the 18 to 25 years old people, but I have to take away anyone who's in both of those groups. And in this case, we're very fortunate that there is no one in the intersection of those groups. So I would not be risking a miscalculation if I forgot to include the intersection. But we do need to make sure we remember to do that because in most cases there will be people in the intersection. So divided by 515. So we end up with 87 over 515, and this can't be reduced, so that's going to be our final answer. So that'll do it for this video. Most Wednesdays, this is what we'll do when we have remote days and I send asynchronous material. We'll use a combination of Edpuzzle and maybe Delta Math in some cases, but just to keep you thinking about what it is we did in the previous day and get you ready for the next lesson.